Again, welcome back to Unit 6, Part 3 lectures. In these lectures, we're going to cover the confidence intervals for population proportions. So our main objective is to find a point estimate for the population proportion. We're also going to learn how to construct a confidence interval for a population proportion, and also how to determine the minimum sample size required when estimating a population proportion. So here we said a population proportion is the probability of success in a single trial for a binomial experiment. And normally we represent population proportion by the letter P. Also, the point estimate for P will be the proportion of success in a sample. The proportion of success in a sample. And this normally will be represented by P hat. So P hat is X divided by N. So this will represent the proportion of success in a sample because S will represent the number of success in a sample divided by the N, which is the sample size. So always the P hat is less than 1. It's more or less finding the proportion of a number of success in a sample size. So point estimate for population proportion, here we use, as we said, the lowercase p as proportion. So here estimate the population parameters, the proportion p. Now, in terms of sample size, proportion of a sample size will be the p hat. So the point estimate for Q will represent the proportion of failures. So in our probability lectures, we had the letter P representing the probability of success and Q representing the probability of failure. So normally to find the probability of failure, it will be 1 minus the probability of success, because we know the total probability value is 1. So the same thing apply here. To find the Q hat, and the hat represent the sample. We are dealing with the sample statistic. So Q hat will be 1 minus P hat, which is 1 minus the probability of success, will give us the probability of failure. So now let's see one example. The example here, we are going to find the point estimate for P, again, the population proportion. So here, in a survey of 1219 US adults, 354 said their favorite sport to watch is football. Now find a point estimate for the population proportion of US adults who say their favorite sport to watch is football. Now here we know the total sample size, which is the survey of 1219 US adults. And out of the 1219, 354 said they like football. So to find the population proportion of US adults, then it will be, again, 354 divided by 1219. So the 1219 will represent our sample size, and X will represent the number of success. So it will be 354 divided by 1219, which will give us roughly 0.290402, or 29%. Now, next we discuss the confidence intervals for P. So, say confidence interval for population proportion P, and normally we again, point estimate normally give us a specific one value. Confidence interval will give us some interval values. So here, to find the point estimate, it means we are looking for exact value of P. But now we want to look for the interval. So the interval will be the error, or the E, the P minus the E, and also the P plus E. So the interval will be between those two values. Now to find the E, it will be ZC P hat times Q hat divided by N. Now here we are using the Z-score or the Z value. So again, that's this formula will give us a confidence interval. We have the E value. We subtract the E value from the P hat. That will give us the lowest value to the highest value, which will be, we had the E value to the P. So here we say the probability that the confidence interval contains P is C. So the steps to solving this problem or constructing the confidence interval for P is, first we need to identify the sample statistics N and also the X. S will be the probability of success. Then we can find the point estimate first. Now, when we get the point estimate, we need to find the E. Then the interval will be the point estimate minus E to the point estimate plus E. So the next step, we are going to verify that the sampling distribution of P hat can be approximated by the normal distribution. And this means NP hat should be at least greater than 5 or equal to 5. Then NQ hat also should be greater than or equal to 5. If we meet this condition, it means that, again, we verify that the sampling distribution of P hat can be approximated by, again, normal distribution. The next step, we need to find the critical value or the E. The Z. After we get the ZC, which is the critical value, then we find the E. Because again, the E will give us ZC times square root of P hat times Q hat over, again, N. So in order to find the critical value, we have to use the standard normal table, because here we are using the Z value. Now, when we get the critical value, we find the error or the margin of error, E. Now, when we get the margin of error, we are finished. Now we can find the interval, the P hat minus the margin of error to P hat plus the margin of error. So those are the 6 steps. Now let's see an example. So here we have an example that in a survey of 1219 US adults, 354 said that their favorite sport to watch is football. We should construct a 95% confidence interval for the proportion of adults in the United States who say that their favorite sport to watch is football. Now, previously, we used this example to find the point estimate. In terms of point estimate, they didn't give us the confidence interval. So in order to find a confidence interval, they're going to give us the percentage. So here we say construct 95% confidence interval. This means the alpha value will be 5%. So the first thing we need to do is to find the P hat. Remember, the P hat gave us 354, which is the X, divided by the sample size, 1219. So 354 divided by 1219 will give us 0.290402. Then we also find the Q hat because we need to find the E. So Q hat will give us 1 minus P hat, which will give us 0.700958. Now, we also need to check for our condition if NP hat and NQ hat is greater or equal to 5. And here, we saw that 1219 times 0.290402 gives us 354, so it's greater than 5. Then 1219 times 0.709598 is approximately 865, which means it's greater than 5 also. So this means we can proceed to find the confidence interval. So we are going to find the margin of error, which gives us ZC square root of P hat, Q hat divided by N. Now, if we have a confidence interval of 95%, which means the alpha is 5%. The ZC, if we look at our table, it will give us 1.96. So we have 1.96. This will be the standard normal table for the Z value. To give us 1.96, we multiply it by the P hat and the Q hat and divide by N or the square root. So that gave us 0.025. Now the next step is to find the confidence interval. We already know the P hat and we know the E. So the lower value will be P hat minus E, which is 0.265. It's 0.29 minus 0.025. Then the upper side, which is the right endpoint, will be P hat plus E, which will give us 0.29 plus 0.025. So this means our confidence interval will be 0.265 to 0.315. Or we will say that the P should be greater than 0.265 and lesser than 0.315. So we plot it here. We can see the lower limit on the left side. We start 0.265 to 0.315. Now we find the point estimate to be 0.29. So our P hat again is the middle 0.29. So here we say with 95% confidence, we can say that the proportion of adults who say football is their favorite sport is between 26.5% to 31.5%. Next, we are going to learn how to find a sample size. In inferential statistics, sample size is very important because sometimes based on the sample size, we can make sure or we can know if our testing, it can be hypothesis testing, etc., is correct, or because the sample size can change, excuse me, can change the decision. So here we say, given a C confidence level, and also if we know the margin of error E, and the minimum sample size N needed to estimate P is given as the following. And we can see that this formula is derived from the formula to find E. Remember, to find E, it will be ZC times square root of P hat Q hat over N. So if we know the P hat, we know the Q, we can know the Q hat because Q hat will be 1 minus P hat. And if we know the ZC, the critical value, and we know E, then we can find the sample size. So here we say this formula, assuming that you have an estimate for the P hat already, and also we have it for the Q hat. If not, we make it even. We use 0.5 for P hat, 0.5 for Q hat. That is if P hat and Q hat is not given, the estimate is not given. So let's see one example here. Here they say you are running a political campaign and you wish to estimate with 95% confidence the proportion of registered voters who will vote for your candidate. Now, your estimate must be accurate within 3% of the true population. Now, the goal here is to find the minimum sample size needed if no preliminary estimate is available, if no. Now, here we can see that we have most of our values here. We have 95% confidence, and also estimate be accurate 3% of the true population. So this means we don't have the P, we don't have the Q. So as we said earlier, since we don't have P and Q, we will say that P hat will be 0.5 and also the Q hat will be 0.5. Then next, we know the confidence interval is 95%. So C will be 0.95. If C is 0.95, from the standard normal table, CC will give us 1.96. And the question, they already gave us E, 3% and 0.03. So if we know this, then we can find N, the sample size, which will be 0.5 times 0.5 over ZC will be 1.96 divided by E, which is 0.03, all square. And approximately, we need a sample size of 1,067. So we run it up because, again, sample will be counting. So we run it up to the nearest whole number. So that will give us 1068 voters. Next example, you are running the same question. This time they say we are running a political campaign which to estimate with 95% confidence the proportion of registered voters who will vote for your candidate. Your estimate must be accurate within 3% of the true population. Find the minimum sample size needed. If the preliminary estimate gives the p-hat is 0.31, again, is the same question from our previous example, but this time the p-hat is given. Previous example, the p-hat is not given, so we say the p-hat to be 0.5 and the q-hat to be 0.5. Now, since the p-hat is given to be 0.31, it means the q-hat will be 1 minus 0.31. So that will give us 0.69. And then we can still get a C. The confidence interval is 95%, so C is 0.95. ZC will give us 1.96 because the alpha value will be 5% or 0.05. And the E is given to us 0.03. So this means we can find the N. So N will be the P carat times the Q carat, which is 0.31 times 0.69. And then divided by ZC, which is again 95% confidence interval. So ZC will give us 1.96. And E is given to be 0.03. So if we do this arithmetic operation, we are going to get 913, which will be roughly, we run it to now around 14 voters. So that will be the summary of these lectures. Again, these lectures, we learn how to find a point estimate. Again, a point estimate will be a specific value for population proportion. So we say the point estimate again is the probability of the number of success divided by the sample size. We also learn how to construct the confidence interval, which will be the P should be greater than P-hat minus E, and it should be lesser than P-hat plus E. We also learn how to determine the minimum sample size that is required in estimating a population proportion. In this case, again, we use the E formula to find the N, the sample size. So again, wish everybody the best and see you in the next lectures.